Hey guys, welcome to this video. In this video, we're going to be setting up our Neptune database on AWS. Let's get started. First of all, let's navigate to the AWS website, aws.amazon.com. Next, let's click on the My Account dropdown and select AWS Management Console. Now, we are in our AWS Management Console. Let's use the search bar above to search for Neptune. And here it is, Neptune, fast, reliable graph database built for the cloud. Let's click on it. Here is our AWS Neptune service. But before we continue, let's talk a little about AWS regions. AWS's network is divided into regions. These regions are positioned in different parts of the world. For this course, we'll be using the Europe-Ireland region. So make sure that you're in this region by clicking on this drop-down and selecting Europe-Ireland, also called EU West 1. This is because Neptune works best in this region, and the reason we're only using this region is because any other region may cause problems throughout the course. So I recommend that you use this one. And also, if your databases and Jupyter notebooks and anything else happens to suddenly disappear, it's because you're not on the correct region, because your instances are only visible in the region that you specify. So in this case, if you create a database inside EU West 1, it will not be visible in any of these other regions. Now, let's get started creating our Neptune database. Let's click on the Launch Amazon Neptune button. Here, we can configure all of the settings of our Neptune database. Let's start from the top. First of all, we have the engine version. This setting configures which version of the Neptune engine we will be using for our cluster. Keep in mind that the words database and cluster both mean the same thing. In this case, we'll choose the latest Neptune engine, which is 1.0.4.2.R2. Next, we have the database name. In this case, we're going to be keeping it as database 1. Next, we have our template. So our database templates configure whether our database will be used in production or for testing and development. In this case, we're going to be choosing the development and testing template. Next, we have our database size. This configures the specs of our database. In this case, we'll be using burstable classes because we don't really need the power of memory optimized classes for this demonstration. The only option available is db.t3.medium. And here are the specs of db.t3.medium. It contains 2 virtual CPUs, 4 GB of RAM, and it has a throughput speed of 1500 megabits per second. These specs are more than enough for our use case, so they'll work perfectly fine with all of our Jupyter notebooks. Then we have availability and durability. This configures whether our database will be available across multiple regions or not. In this case, we'll keep it as no because we don't really need it for this demonstration. Next, we have connectivity. We're not going to be changing any settings over here. Then we have notebook configuration. When you create a Neptune database, you can interact with it through what's called a Jupyter notebook. We'll have a look at it in greater detail in the next video, but for now, you can uncheck the box that says Create Notebook. This is because when you try to create a Jupyter notebook with the Neptune database automatically, it usually doesn't work and bugs out in some way or another, so it's best to leave it for now. Finally, we have tags. Tags are key value pairs that you can configure for all of your services inside AWS. So let's give our Neptune database a key and a value for identification. Let's set the key as Neptune and the value as database. Finally, let's click on the Create Database button to create our Neptune database. Let's wait for our database to be created first. As you can see, our database has now been created. All Neptune databases are divided into two parts. The first is the actual cluster, and the second is the external writer, which also functions like a reader. You can click on the cluster and the external writer to see more details as well. Let's start with the cluster. As you can see, when we click on the cluster, we have a writer and a reader. Basically, what's going on over here is that all Neptune clusters or databases have a built-in writer and reader for reading and writing to themselves. But there's also an external writer, which is this one over here, which also functions like a reader. And this writer is connected to our Jupyter notebook and sends all of our requests to the internal cluster's writer or reader. I hope this video helped you set up a Neptune database on AWS. Hey guys, welcome to this video. In this video, we're going to be setting up a security group for our Neptune database. So let's click on our Jupyter notebook and let's open our Jupyter notebook in a new tab. So as usual, it's going to redirect us to SageMaker, and then from SageMaker, it's going to redirect us to our actual Jupyter notebook. Now once we're over here, we can click on the Neptune folder. And inside this folder, we have all of our Jupyter notebook files as usual. So now we're going to click on our visualization folder, which we haven't touched so far. And over here, we're going to be opening the Air Routes Gremlin notebook. So let's click on that and it'll open in a new tab automatically. So over here, you can see we have our notebook opened up. And what we're going to be doing is we're going to be creating a new cell. So we just opened this for demonstration purposes so we can create a new cell. And we're going to type %status inside. So when you run this command, it's going to show us the status of our Neptune database. So you can see the status is healthy. So our Neptune database is currently healthy. We have our Neptune database start time, which is June 22nd, 18:55:04 UTC 2021. We have our database engine version. We have the role of our instance. In this case, this is a writer instance that also acts like a reader. And we have our Gremlin version, and we have a lot of other random information as well. So all we need to know is that our database is healthy. So now what we're going to be doing is we're going to go back to where all of our database and instance configuration settings are. So we're going to go back to the previous tab. In this case, it's this one. And we're going to click on our database 1, instance 1 writer. So we're going to click on the link itself. And then over here, we can have a look at our connectivity and security settings. You can see this tab over here. And we have our endpoint. So let's start from the beginning. So we're going to examine everything over here on this page. First of all, we have our endpoint. So our endpoint is where we can access our database from. So this is auto-generated, and this is the endpoint which we can use to access all of the data in our database. Next, we have the default port number, 8182. After that, we have our availability zone. In this case, it's US West 2C. So this is also auto-generated. Then we have our VPC. In this case, our VPC is 6C3D0114. We have a subnet group as well. And inside this subnet group, you can see that we have 4 subnets. So subnet 4DD0C066. So you can see the VPC has this subnet group, and then the subnet group has these subnets. So we have subnet 4DD0, subnet 22F4, subnet 96AE, and subnet 3079, just saying the first 4 letters. And then in the security portion, we have our security group. So this is basically responsible for securing all of our data, as the name suggests. And what we're going to be doing is editing our security group to contain a new inbound rule. So this will affect our VPC as well. So we're going to go into our networking settings and go to the security group section and click on our security group. So in this case, our security group is called SGCDEEDAFF. So now we're going to click on the Edit Inbound Rules button. And over here, by default, it only allows internal traffic. So we're going to remove this over here, and inside the search bar that you can see right above it, so this one over here, we're going to be entering the IP that we're going to be using. So that's 172.31.0.0/16. So our CIDR number is 16. Then we're going to save our rules, and as you can see, the rules are now processing. So over here, you can see that we just changed our source. So now it will be able to receive data from the specific IP that we specified. So that is really good, because now we can use our S3 bucket and load our data from our S3 bucket to our Neptune database, which we couldn't do before because everything worked internally, so we couldn't really access it. And you can see over here that our security group still remains the same, our public accessibility is still no, but this is now basically changing the database so that it accepts accesses from this IP over here and not just all of our internal resources. So that's really cool. So thanks for watching this video, guys, and in the next video we're going to be working a little more with this whole data loading issue, and we're going to be loading our dataset into Neptune. Hello everyone, welcome to this video. In this video we're going to be doing the last step that we need to actually load our data from our S3 bucket to our Neptune database. We're going to be creating an endpoint. So first of all, go to the search bar and search for VPC, or you can click on it directly from here if you have it. So once we go to this page, on the left you can see we have a lot of options. So click on the endpoints option. So you can see currently that we don't actually have any endpoints. Once this loads, you can see that we don't have any endpoints. So first of all, what is an endpoint? So an endpoint is basically a point in the middle of two different services, in this case our Neptune database and our S3 bucket, and this point is actually exposed. So we can use this point to communicate between the two and give instructions. So what we're doing right now is creating an endpoint between our Neptune database and also between our S3 bucket. So we're going to click on the Create Endpoint button. So over here we have a search bar. Now inside the search bar, you can search for S3. And over here, you can select the gateway option. So click on this radio button over here. And then you can click on this route table ID that you can see over here. So this route table basically contains all of the subnets, and you can see that the VPC that we've chosen is the one that we configured the IP with before in a previous video, and is also related to our Neptune database itself. So we can click on the check icon over here, and it's going to select all of the subnets inside our security group that we configured in a previous video as well. So after this, we have our policies. So we can either do full access or custom access. So full access is just default, and custom access is specifying custom JSON or custom accessibility. So we're just going to go with full access. And now we can click on the Create Endpoint button. So you can see that our endpoint has now been created, and we can click on the Close button. And over here, if you refresh this, you can see that we now have an endpoint over here. So you can see that we have a lot of details of the endpoint as well. We have our endpoint ID, the status, the creation time, the type, in this case it's a gateway, the DNS names, the VPC ID, the service name, and all of this stuff over here. So this is the final step that we need to do to actually load data from our S3 bucket to our Neptune database. I hope this video helped you understand how to configure an endpoint so we can transfer data from our S3 bucket to our Neptune database. Hello everyone, welcome to this video. In this video, we're going to be loading our dataset from our S3 bucket into our Neptune database. So finally, the time has come. You are now ready, and now we're going to be loading our data. Let's go. So first of all, let's have a look at our S3 bucket. So our S3 bucket is called Neptune's 3DB. Now, this isn't the same bucket that we made before, so you can use the same one that you have as well. So you can see that this bucket has two CSV files, error edges and error nodes. So these are our nodes and edges CSV files. So what we're going to be doing is we're going to be using this bucket and using the CSV files inside them to load the data. Now over here, you can see that I'm in my Jupyter notebook. So over here, I'm just going to open a random notebook. So in this case, I'm opening about the Neptune notebook. And from here, I'm going to click on the File button, click on New Notebook, and click on Python 3 to create a new Python 3 Jupyter notebook. Now, first of all, I'm going to rename this notebook, and I'm going to call it Load Data from S3. And then I'm going to click on the Rename button. Now, over here, let's start with using the status magic keyword. So let's check if our database is up and running and whether it's healthy or not. So you can see that our database is healthy, everything's going fine. We have all of our other stuff as well, like our start time, DB engine version, role, the Gremlin version, etc. And now we're going to be using the load magic keyword to actually load the data from our S3 bucket into our Neptune database. We have a lot of options over here, so let's get started. Now, first of all, we're going to be starting from the source. So this is basically where you specify the S3 bucket. So going back over here, our S3 bucket is called Neptune's 3DB. We can copy this URI over here and we can paste it over here directly. Although this has now pasted the URI for our airedges.csv file. We need to paste the URI for our bucket so that it automatically takes both CSV files at once. So to do this, we can just remove airedges.csv at the end, like so. So now it's only s3://neptunes 3db. Next, we have our data loading format. We're going to be using CSV as that's the only supported data type with Gremlin. And after that, we're going to be having a look at our AWS region. So our AWS region is basically where our dataset, this bucket that you can see over here, our CSV files are located. So in this case, for this example, we're using US West 2. But throughout the course, we use EU West 1. So just configure the correct region that you're using. Then we have the load ARN. So to configure this, let's go back. And over here, we're going to have a look at our IAM role that we created in a previous video. So our IAM role is called Neptune load from S3. We're going to go in here and copy this role ARN that you can see over here. So let's go back and now let's paste it into this empty area that you can see over here. And now we have pasted our load ARN. Next, we have our data loading mode. So we're going to be choosing auto, although there are a few other options as well. We have resume and we have new. We're just going to use the auto option. Then we have fail on failure. So fail on failure basically configures whether this, if the data loading fails, then will it fail or not. So in this case, we can take this as true. But what we're going to be doing for this example is we're just going to keep it as false. So let me just change this and we're just going to keep it as false for now. And next we have parallelism. Now parallelism, in short, is basically the speeds at which we are uploading the data. So we can use low, medium, high, or oversubscribe. Now because this is just an example video, we're going to be using oversubscribe, the fastest option available. But note that this might corrupt the data in some way or another. I recommend you use low or medium. Next, we have update single cardinality. This is used if we already have a database and we want to replace the data or change the data inside it. So in this case, update single cardinality is just going to be placed as false. Next, we have queue request. So we don't want to put this in a queue because we don't have any other processes. So we're just going to leave it as false. And then dependencies, we don't really have any other dependencies. So now we're just going to click on the submit button. And over here, you can see that the data is being loaded from our Neptune bucket into our Neptune database. So over here, you can see that the load is currently in progress and now, great, it's been completed. So our load has completed successfully. It has taken a total of 8 seconds. So you can see that we have finally loaded the data into our Neptune database from our S3 bucket. So next, we're going to be working on some practical projects. And just before we finish the video, let's have a look at an example Gremlin command to see if everything loaded properly or not. And great, all the data has loaded successfully. So this is just an example. We're having a look at 10 vertices and we're value mapping them according to their default label format. So you can see that everything is displaying as it should. So that's going to be doing it for this video. In upcoming videos, we're going to be having a look at some projects that we can do with Gremlin. And that's just going to be it for this data loading section. You've learned how to load data from S3 into our Neptune database, configure all of the endpoints, create the database itself, create the Jupyter notebook, and all of that nitty-gritty stuff that you need to do. So thank you guys for watching this video.